Now, it is very possible for us to be given a right angle triangle in which we're going to be asked to find the side. Now, in the initial example, we solved to find the unknown, which was in that case the hypotenuse. But in this example, we're going to be trying out something new. Let's see if we can find any of the other sides. So for this example, we have our right angle triangle ABC. Now, AB is 3 centimeters. BC is X centimeters. And our AC here is 5 centimeters. Okay. Now, let's go ahead now and solve this. So, according to our Pythagoras theorem, we have 5 square on our left-hand side. It's equivalent to 3 square plus x square. That is, 5 square is equal to 3 square plus x square. Now we're looking for x, remember. Now that was the theorem, remember, that the longest side of a right angle triangle, that's the square of the longest side of a right angle triangle, is equivalent to the squares of the sum of the other sides of that right angle triangle. Okay, so now we have 5 square is equal to 3 square plus x square. Now, if 5 square is equal to 3 square plus x square, it's still the same thing as saying 3 square plus x square is 5 square. Yes. So you can rearrange your equation, all right? And then you now take 3 square plus x square to the left-hand side. It's always very, very good when you put your unknown at the left-hand side of the equation. All right, try to isolate the unknown at the left-hand side of the equation. It makes more sense. Even the presentation and the way you solve it mathematically makes more sense in that order. All right, so now we are having our what? 3 square plus our x square at the left-hand side. Now our 5 square is now at the right-hand side. Please don't get confused. If I say 3 times 2 is 6, it's the same thing as saying 6 is equal to 3 times 2. So please don't be confused by this. All right, we just switched to the other side. Like I said, it makes more sense mathematically to leave any unknown at the left hand side. The presentation, the way it comes, it makes sense. All right, it's presentable that way. All right, so let's continue now from where we stopped. So we're having 3 square plus x square, or x square plus 3 square is equivalent to what? 5 square. Now, at this point, we are going to try to eliminate 3 square because 3 square right now is disturbing x square. What do I mean by that word, disturbing? It's the only thing that is attached to s square at the left hand side. If you want to find your unknown in mathematics, you have to isolate that unknown, which in this case is x. X is our unknown, so 3 has to disappear. Now, so we're going to be having our s square alone at the left hand side. Yes, you have to make sure you isolate the unknown for every equation you're solving. That is important. All right, so our 3 square will now give way because we are now going to be subtracting 3 square from the left hand side. But remember, in mathematics, it is a crime for you to do a basic operation at the left hand side and forget to do the same at the right hand side. All right, so if you are subtracting 3 square from the 3 square at the left hand side, make sure you do the same at the right hand side. Now, if we do that, we're now going to be having x squared is equal to 5 squared plus 3 squared. Sorry, minus. Because now, why is it minus? Because we subtracted 3 squared from the left hand side. Now remember, 3 squared minus 3 squared will now give us 0, which is nothing, so it will disappear. That's why we're having our s squared now left isolated at the left hand side. Now at the right hand side, we're having 5 squared minus 3 squared. Now, with that, we can now move to the next step. All right. So remember, in our last example, I told you, you introduce what is known as what is square root. If you introduce square root in this case now on both sides of the equation, we're now going to have something that looks like this. Roots x squared at the left, and then on the right hand side of our equation, we're now going to be having roots 5 squared minus 3 squared. Yes! 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 Okay, so with that now, our root will cancel our square at the left hand side. Our x will be there. And then going back to your right hand side, you are left with your root and 5 square minus 3 square. 5 square is 25. 3 square is 9. 25 minus 9 will give us 16. So we are now left with the root of 16 at the right hand side. So your x is now equivalent to what? The root of 16. Wow! Now, the root of 16 will now give you what? 4. So your x will now be what? 4, which is what? 4 centimeters. Remember, in our last example, 4 was among the sides. So we're looking for what? The hypotenuse, which is now what? 5 centimeters. So now we've now gotten our 4 centimeters where it wasn't given here. Now, that is how you solve to find a side that is unknown in a right angle triangle when given the hypotenuse and another side. Simple!